The supernova of Betelgeuse is one of the astronomical occurrences that is most anxiously anticipated. Betelgeuse is a red supergiant star in the well-known shoulder of Orion that is on the verge of extinction. One of the brightest stars in the night sky, Betelgeuse inexplicably started to dim in the later half of 2019. The fading was so clear that one could even see it without glasses. Betelgeuse's brilliance decreased for several months, leading astronomers to wonder if the star had reached the end of its existence. But after a few months, the red giant star's brightness leveled down. When astronomers concentrated some of the most powerful telescopes on it, they were shocked to find the source of the significant dimming. As this star draws closer to the end of its life, it is about to erupt. A supernova is anticipated to occur when and why? And will the consequences for Earth be catastrophic? Let's investigate. In the top right shoulder of the winter constellation Orion the Hunter, the vivid ruby-red dazzling star known as Betelgeuse may be found. The second brightest star in the constellation after the blue supergiant Rigel, it is often referred to as Alpha Orionis. Because of its changeable nature and peculiar name, Betelgeuse makes for an interesting target for astronomical research and observations. Even though Rigel, Orion's other brilliant star, is brighter, stars with the name Alpha are often the brightest in their constellations. It is Alpha Orionis, Betelgeuse. It is also one of the most well-known stars because to its name, brightness, size, and reddish color. Betelgeuse is the 10th brightest star overall in the sky and the 7th brightest star that can be seen from most of North America, Europe, and Canada. The Arabic phrase that served as the inspiration for the name Betelgeuse is sometimes translated as the armpit of the giant. Although some historians believe that Betelgeuse shows a hand or maybe a shoulder rather than an armpit, it is obvious that the giant relates to Orion. Many antique star charts show Betelgeuse as Orion's right shoulder, although its exact meaning is uncertain. Given that in ancient mythology Orion is most frequently associated with a giant, a warrior, a hunter, a god, or some other anthropomorphic or animal form, it is not unexpected that Betelgeuse is most frequently shown with an anatomical relationship. Surprisingly, even though scientists estimate Betelgeuse's distance from Earth to be between 430 and 724 light-years, astronomers are unable to determine its precise location. The brightest red supergiant star and one that is nearest to Earth is Betelgeuse. Only 200 red supergiant stars in our galaxy have been found. The Sun's mass is 16.5 times that of Betelgeuse. The supergiant is 548 light-years distant and has 126,000 solar luminosities. This star is colder than the Sun, with a surface temperature of 3,600 Kelvin. Visible light only makes up around 13% of Betelgeuse's radiant energy. The brightest star in our night sky, Betelgeuse, would surpass Sirius if human eyes could perceive light at all wavelengths. The Betelgeuse radius is around 764 times greater than that of Sun. It would extend across the asteroid belt and even beyond Jupiter if this star took the place of our Sun in the solar system. This means that the entire solar system, Earth, Mars, Mercury, and Venus, would be engulfed. Every 10,000 years, Betelgeuse loses around one solar mass. The red star is ejecting material unevenly in all directions, creating a nebula around it. Betelgeuse is surrounded by a cloud of material that is 250 times bigger than this star, and the size of this nebula is estimated to be 30 astronomical units, AU, or 30 times the Sun-Earth distance. This separation exists between the Sun and Neptune, the solar system's farthest planet. Betelgeuse, a red supergiant, is thought to be between 9 and 10 million years old, which is still rather young. Supergiant or red giant stars are thought to be reaching the conclusion of their lives. A star is formed of hydrogen when it first forms, and under the influence of gravity, the hydrogen fuses together in the star's core to produce helium in a nuclear explosion. During the fusion process, a lot of heat and light energy is normally emitted. As it approaches the star's surface, this energy emits a photon into space. The star's main fuel, hydrogen, runs out as it ages, and as it becomes older, helium begins to fuse with carbon to produce carbon. Neon will ultimately react with carbon to make iron when the helium has been consumed. This causes the fusion of neon and iron to absorb energy rather than release it. When iron starts to fuse, the star collapses in on itself due to the lack of anything to obstruct the star's extremely strong gravity, resulting in a supernova explosion. One of nature's most potent forces, a supernova can produce more energy than 10 billion suns. Depending on what stage of their stellar evolution they have reached, stars change color during the course of their existence from the youngest, hottest blue forms to the older, cooler, red kinds. Strangely, the Greek astronomer Ptolemy, who lived from 90 to 168 AD, described Betelgeuse's hue as having a ruddiness. However, Chinese astronomers had described the star as having a yellow tint 3 centuries earlier, potentially indicating that Betelgeuse was formerly a yellow supergiant. Larger stars usually exhaust their hydrogen more quickly and go extinct sooner. Betelgeuse, albeit just about 10 million years old, is undoubtedly reaching the end of its existence. On the other hand, at little over 5 billion years old, our Sun is still in its prime. Additionally, a supernova could happen shortly since Betelgeuse is reaching the end of its existence. The exact date of Betelgeuse's supernova, however, is fiercely debated. Betelgeuse experiences 2 dimming and brightening cycles, the second of which lasts around 100 days and happens about every 5 years. During this cycle, the star's outer shell is theorized to grow and shrink, affecting the star's diameter and average temperature as the cycle progresses. Betelgeuse's irregular fading in 2019 and 2020, which was followed by a temporary return to its regular brilliance, attracted a lot of attention. Astronomers think it may be a sign that the star is going to die. Since the 1st century BCE, Betelgeuse has been the subject of extensive research. Why, though, did it fade abruptly and against its typical cycle? Betelgeuse has been observed traveling through the interstellar medium at a speed of 30 kilometers per second after being evicted from its home in the Orion OB1 association, which is made up of the stars in Orion's belt. This accelerating star is generating a bow shock that is more than 4 light-years wide. In astronomy, it is challenging to calculate the distances to red supergiant stars like Betelgeuse. For a number of reasons, it has been difficult to determine Betelgeuse's actual diameter. As a pulsing star, Betelgeuse's diameter varies over time. Due to limb darkening, the optical emissions change in hue and become weaker the farther they are from the center. The star therefore lacks a definite edge. It is challenging to pinpoint Betelgeuse's photosphere due to the circumstellar envelope, which is composed of material expelled from the star and emits and absorbs light. It is challenging to compare observations since the apparent size of the star fluctuates depending on the wavelength used. Measurements can be made at different wavelengths within the electromagnetic spectrum, and the reported diameters can vary by up to 30% to 35%. The European Southern Observatory published images collected by the ground-based Very Large Telescope Interferometer, or VLTI, in July 2009 that revealed a massive gas plume that extended $30 from the star into the surrounding environment. The size of this mass ejection, one of several that took place in Betelgeuse's atmosphere, was equivalent to the distance between the Sun and Neptune. At least 6 shells have been found to encircle Betelgeuse, according to astronomers. It would be possible to ascertain the cause of these stellar giants' awful demise by unraveling the enigma of mass loss in the last stages of a star's existence. Concerns have also been voiced about Betelgeuse's extensive atmosphere's complicated dynamics in addition to the star's diameter. Although it is yet unknown how mass is lost, red supergiants are important in the recycling of the stuff that makes up galaxies. Astronomers could be close to finding a solution to this issue as a result of developments in interferometric methods. Hubble and other observatories were used by astronomers to determine that the star produced a significant surface mass ejection, SME, in 2019 and expelled a significant portion of its visible surface. This conduct in a celebrity has never previously been observed. Coronal mass ejections, or CMEs, are periodical eruptions of the Sun's thin outer atmosphere, the corona. This can be explained by the fact that the Betelgeuse surface mass ejection, or SME, released 400 billion times more mass than a normal coronal mass ejection, or CME. Betelgeuse started to decrease significantly in October 2019, and by mid-February 2020, it had lost around 3 times as much brightness from magnitude 0.5 to magnitude 1.7. Betelgeuse's brightness had been consistent for over 10 days by February 17, 2020, and the star had begun to brighten once more. However, 5 days later, Betelgeuse looked to have entirely stopped dimming, essentially concluding the dimming event. It seems that the recent visual fading was unconnected to the projected core collapse because there were no discernible changes in the infrared on February 24, 2020. Another investigation that day found that the star's dimming was most likely brought on by circumstellar material that was occluding huge grains of dust. The study, which makes use of data at submillimeter wavelengths, disproves the possibility that dust absorption has a substantial impact. Large star spots, however, seem to be the source of the fading. Additional investigation revealed a sharp increase in Betelgeuse's brightness. On August 30, 2020, researchers discovered a second dust cloud emanating from Betelgeuse, which was connected to a recent significant decrease of the star's brightness. A core area on its photosphere was suspected to be the source of the dust in June of last year, and the initial theories were supported in August by a second independent analysis. The gas that the cooling star emitted is assumed to have produced the dust. Occluding dust may have been produced by a surface mass ejection, according to research done in 2022 with the Hubble Space Telescope. Millions of kilometers distant, the material that was blasted from the surface of this star cooled, compacted, and eventually became the star's fading dust. The photosphere, which was about several times as heavy as our moon, broke apart and floated off into space, covering the star from watchers on Earth with a dust cloud. Even backyard watchers who saw the star's brightness drop could clearly see the fading, which started in late 2019 and lasted for a few months. What's more amazing is that the supergiant's 400-day pulsation rate has stopped. Astronomers have been observing fluctuations in Betelgeuse's surface movements and brightness variations for around 200 years in order to trace this cycle. The size of the blow is revealed by its disruption. Now, astronomers have created a possible explanation to explain the disturbance. The star is gradually recovering strength as the photosphere renews as well. The inside of the star is shaking like a bell that has been hammered as its regular cycle is being disrupted. These results provide insight into how red stars age and lose mass, eventually exploding as supernovae when their nuclear fusion furnaces exhaust their fuel supply. Their fate is significantly influenced by the degree of mass loss. Betelgeuse's extraordinarily impolite behavior is also not a sign that the star will suddenly become well known. So, a large loss event is not always a precursor of an impending explosion. Betelgeuse is currently having difficulty healing from this injury. Convection cells within the star are assumed to be spinning about like an unbalanced washing machine tub, producing the frequent pulsing. The surface is bouncing like a plate of gelatin cake as the photosphere reconstructs itself, according to trace and Hubble spectra. The topmost layers, though, seem to be getting back to normal. Astronomers have never seen such a big portion of a star's visible surface get hurled into space, even though our Sun frequently experiences coronal mass ejections that blast off tiny portions of its outer atmosphere. Because of this, coronal mass ejections and surface ejections can occur separately. The surface mass ejection of a large star has never been seen before, according to scientists. We still don't entirely understand what is happening, but something is. We can utilize Hubble to identify surface properties while directly observing this novel occurrence, tracking the evolution of stars in real time. NASA's Webb Space Telescope could be able to observe the material being expelled from the star as it continues to travel away from the star in infrared light. Betelgeuse's fading
as the ejected material continues to move away from the star in infrared light, NASA's Webb Space Telescope may be able to see it. The fading of Betelgeuse has finally stopped and could reclaim its ranking as the 10th brightest star in the sky. Betelgeuse is around 100,000.
Energy requires rapid fuel consumption, hastening its demise. The star will ultimately exhaust its fuel, collapse under its own weight, and finally explode as a brilliant supernova. Betelgeuse will then become extremely brilliant for a few weeks or months, potentially matching the brightness of the full moon. Throughout the day, it will become apparent. When will it happen? Most likely not throughout our lives. But nobody genuinely knows with certainty when it will occur. It might occur today or in a million years. Will Earth be destroyed by the Betelgeuse supernova? No. Life on Earth won't be affected by the explosion of Betelgeuse, as it will take place too far from the planet to even partly destroy it. A supernova would have to be 50 light-years away from us in order for humanity to be in danger, according to astronomers. As we all know, Betelgeuse is also nearly 10 times farther distant. Instead, everyone on Earth will have an incredibly spectacular vision of an extremely brilliant star in the night sky at that moment. Finally, because to Betelgeuse's close vicinity, scientists will be able to observe the star's explosion while it is occurring. We appreciate you watching our new Humanity Timeline episode. Please click the video on your screen to view more astounding space videos while you are still here.